All right, greetings everyone and welcome to my channel. I am Professor L and this is Friday night and I am going to be continuing where I left off yesterday, but just a reminder that this is a live stream intended for math help. So if anybody has a math question that they would like to see worked out, I can't promise you that I know how to work every single problem, but if I can work it out, I will do that on my board. I'll interrupt my lesson and work a problem. I prefer to help students with their math, but I also want to remain useful in this time. So in the meantime, I'm just going to be informally presenting a topic, and hopefully this benefits someone. I'm going to be today discussing, well, it's the topic trigonomeric inverse functions, but specifically I'm going to be graphing the sine and the cosine and arc-sine and arc-cosine. So I started yesterday and my camera died tragically. Gonna try to remember to charge it daily until I get better equipment. But I went ahead and left this up so that I could pick up where I left off. And I'm just going to go ahead and get into the math. Hopefully my marker's not too squeaky. If not, I got it back up here. All right, so recall from yesterday, I started talking about the sine function. And this week we've kind of been talking a lot about the graphs of the trigonomeric functions. And I tried to move on to a topic on inverses, trigonomeric inverse functions. And so we decided that the sine function is not a one-to-one function, so it's not invertible unless you restrict the domain. And so that's what we've done. We've restricted the domain of the sine function so that we can invert the function, find its inverse. Well, we already know the inverse of the sine function. It's this funny looking notation function here where it's got this -1 and of x. So there's a lot of different things going on. So it looks kind of complicated, and it is. It's abstract, but like most of the math notation, it seems abstract at first. But after you use it enough and the more time you spend with the function, the more familiar you'll get with it. So we are looking over here at the arc-sine function here, and y sine inverse of x. And recall what we know about inverses. Essentially, they have a unique relationship with their original function where they you're literally just swapping out the domain and range. And what that boils down to is just switching out. If you have a table, you would just switch out your values and then your table. So notice here, these are like a reflection of these points here. I wasn't making a mistake. I was just literally swapping out the domain and range of the function, which is a typical way of finding a function's inverse. If you are only given a table of values, you would just switch them out and say the special inverse notation. So we had pi over 2. What I've decided to do, though, because this is just as much about me getting practice graphing these functions as it is attempting to try to explain an advanced topic and put it in kind of simple terms. So what I've decided to do is go ahead and calculate one more value in here in this symmetrical graph. And in order to do that, I have to come over here to my little mini unit circle here. So remember, this is a unit circle. Radius 1, x squared plus y squared equals 1. And that is a rough sketch. But what we're doing is we're just going to recall pi over 2 and negative pi over 2. And we're just going to drop a 45-degree angle right here, pi over 4. And then this one would be negative pi over 4. And visually, you can see that this 45 is nested in between this 90 and negative 90-degree angle. So where it should exist in the table is right in here. So I might have to just go ahead and erase. So we've got, this one would be negative pi over 4. And this is mainly just so that I'm demonstrating what the difference is mathematically, or I guess you would say algebraically, showing you, I want to show you the difference of what these functions are doing and how they differ. So I don't know what this value is yet, so I'm going to leave it blank because we're going to calculate that in just a minute. And then I'm going to put 0. I'm going to go ahead and move this down. We'll worry about that one later in just a minute. So I need a bigger table, so extend this down. And then I'm going over here after 0, I've got pi over 4. And again, I'm listing these points in ascending order from least to greatest point, starting at the leftmost point out here, negative infinity, and moving just like you would read a book. You're going to read that graph from left to right. Okay, so then we got pi over 2, and then that's where we're going to end it. So we knew these values for the 4 corners, but do we readily have the sine value memorized for pi over 4? And I do. I remember. So I've drawn those triangles so many times that I finally have that value memorized. It's radical 2 over 2, comma, radical 2 over 2. Good. There's hope for me yet. Okay. So again, when we're pulling the values from the unit circle, we're looking at the x component for cosine and the y component for the sine value. And we have this value right here for negative pi over 4. And then, so again, it's going to be radical 2 over 2. And then remembering the sign of the quadrants, recall we need that up here, I guess, quadrant 4. Okay, your cosine is going to be positive and your sine value is going to be negative. So that'll be negative radical 2 over 2. Okay, good. So my sine value here at negative radical, or sorry, negative pi over 4 is going to be negative radical 2 over 2. Okay. And then looking at 0 degrees, we've got a sine value of 0. And then positive pi over 4, we have radical 2 over 2. And then at pi over 2, it looks like the sine value is back to 1. Okay, good. So what we're doing essentially when we're figuring these out, if we didn't have the unit circle, then what we would do, I'll just do one for example, and then I'll start talking about the arcsine. We'll take y equals sine, plug into their domain your angle at negative pi over 2, and the sine of pi over 2 is negative 1. Okay, negative pi over 2 right here. It's negative 1. Okay, good. All right, so what we've done is we've done this process for each one of these angles, and we've returned the value in the range. And we discussed that the sine function, we restrict the domain, however, the range was only between negative 1 and 1. So it was only existing here. From positive 1 on the y-axis. Let's switch this marker over. Okay. All right, much better marker. Okay. It's nice to write with a clean marker. All right. So we've got 1 and negative 1, and this is the only place as far as the range this function is going to exist. It's not going to exist up here or down here. And then we also restricted the domain from, let's see how we want to mark this, negative 1, positive 1. And I've got to figure out what negative pi divided by 2 is. And pi is approximately 3.14159. See how many digits of pi I can remember. I used to have quite a few. It's fun when I was younger. Memorize digits of pi in my spare time. All right, so pi over 2 is approximately 1 point. Here, we'll do it like this. I'm going to put it, we'll need it up here somewhere. So we've got pi over 2, and we divided that, and I got 1.57096,327. And I need one more calculation. I need to know the value of radical 2 divided by 2. So we're also going to do that approximation. Because I'm drawing a rough sketch in my graph. And so I want to know approximately where this point lies, and it doesn't have to be exact because we're just getting, in a rough sketch, you get exactly what it sounds like, a rough sketch. And so we don't want to overthink that. So I'm going to get an approximation for radical 2 over 2 just to estimate my point. Okay. All right. And I've got radical 2 divided by 2 approximately 0.70710678112. Okay. And again, it's good for me to discipline myself to get, because when I remember whenever I was really heavy into this math, many years ago, I would have to carry out that decimal. When I do my approximations, I would have to take it all the way out and put all those digits in there. And I'll tell you, some of the students that are taking these math classes, and you're having an issue with how you're entering your answers in those online homework platforms. The different colleges and community colleges like to employ online formats, and the number one Frustration is you're not carrying your decimals out far enough, or it's how you're rounding your answers in there. And it's so frustrating because you've done everything correct and then you're off by just a couple of decimal places and you get the whole thing wrong. It's tragic. All right. So what I'm doing is I'm over here and I'm going to mark these points, but I want to make sure that I'm kind of marking them correctly. So if I have positive pi over 2, approximately 1.57, then I have negative pi over 2, which is this first point that I need to mark. And it's lying somewhere between -2 and -1. And it looks like it might be closer to -2, so we're just going to put that point in there, negative pi over 2. Oh, yeah. Okay. And so then I also have this point approximated as well. And so I want to put that also in my graph. So I'm going to do that. And pi over 4, negative pi over 4 is, it's between 0 and 1 because it's negative 0.7. So we're just going to put pi over 4 like right in here. Negative pi over 4. And then we have our 0 point. And then we'll skip that one over just a little bit. Okay, that looks better. And then I'm going to go over here on the other side, the positive realm, and put these other points in. So, and we're going to have to also do this for the y-axis because I've decided that I don't want to plot these functions separately because they're inverses and because they have a relationship. I want to make sure that I'm showing you that the symmetry that I talked about yesterday, where you're going to have a symmetry about that identity function line. And I really want to get an accurate sketch because I realize that a picture is worth 1,000 words. Okay. An accurate sketch is really, really important. All right, so then we have 0.7 about right here. So we'll say that's pi over 4. And then negative or positive pi over 2 is 1.57. So it's almost halfway, a little bit closer to 2 for your pi over 2 value. And I think I have all of them in there. So we've got negative pi over 2, negative pi over 4, 0, pi over 4, pi over 2. Perfect. And so then hopefully it won't be taking me as long to do on this axis. So we're just going to drop that point in there, pi over 4, come up here, drop 2, and then we'll say pi over 2 is about right here, pi over 2. And then do this one more time down here for the, down here in these lower quadrants. So we've got negative pi over 4. And that looks, it's all right. Negative 2, and then we've got about right here will be negative pi over 2. And I know that that's a lot of values, but whenever you're swapping your domains, it makes it a little bit easier to graph here in a second. Okay, so I'm going to try to fit Arc-Sine maybe here at a row. So we're going to say Arc-Sine. Okay. And in parentheses, it's y equals sine inverse of x. Okay. First thing I want to do is state the domain and range of this function. Okay. So I'm going to find the domain range by looking at the domain and range of my original function. So I'm going to find the domain range by looking at the domain and range of my original function that I'm going to invert. and I'm going to swap them out. So I'm going to write for my domain, it's going to become the range here is -1 to 1, positive 1. So this is my domain now of my Arc-Sine. And my range is going to be my domain. Okay, so that's -pi/2, comma pi/2. All right. And then the next thing I want to do is create a table of values. Oops. And I'm going to list my domain and my range. And more importantly, this is the values that I'm going to pick for my domain, and I'm going to evaluate my function in my range. Now, I could just find the values by plugging in or swapping your domains and ranges. However, what I'm going to do is I want to show you, I'm going to pick values for my domain, for my Arc-Sine. What I'm doing is this becomes the domain of my my domain values for my my inverse function. So I'm going to go least to greatest, -1, negative radical 2 over 2, 0, positive radical 2 over 2, and 1. And what I'm doing is essentially, and we'll go ahead and start here. You're plugging in an angle. Well, we'll start with the Arc-Sine. We'll start here. Let's see. You've got y equals sine inverse, and then you're going to open our parentheses and you're going to plug into the domain. What you're doing is you're plugging in values. So you'll say, when is Arc-Sine -1? And so it's plugging in the value and it's going to return to you an angle. Okay. So instead of getting an angle and returning a value, you're plugging in a value and it's telling you the angle measure at that value. However, since you have a restricted domain, it's only going to return an angle between -pi/2, pi/2, essentially only existing in the first and fourth quadrants. Okay. So for this function, it only exists in quadrant 1 and 4, this Arc-Sine. So if you try to put an angle that's not in, if you try to put an angle in, or try to put in a value that's not, let's see, what am I trying to say? It'll take, okay, it's only existing between -1 and, -1 and +1. Okay, so it's only this little area around the origin. And so if you try to put a value that's outside, it's going to give you an error. And it'll say, and then the error in your calculator will say domain issue. Okay, and that's why. But -1, okay, is in the domain of the function. And so we're going and looking at the unit circle, and when is the sine equal to -1? Or you could plug it in your calculator. The calculators, they have arcsine, cosine, and tangent. But what is this function actually doing? It's important to know how to make all these calculations by hand before you go and use a tool to do it, okay? Because that's you taking care of your own understanding. All right, so we're going over here and looking. When is the sine equal to -1? And it's at -π/2. So I'm going to say -π/2. And then you go and say -π/2. And then you go and for the next value. And when is, so the answer is -π/2. When is, and we'll do one more before we just go and swap them out because I realize I'm taking a lot of time. And we really don't need to do this for every value. Just a couple of, quick examples and then you're good. So we got sine inverse of -2/2. And when is sine inverse -2/2? It's at -π/4. Or you could say -2. Look at your unit circle right there. And it's -π/4. But if you're familiar with the sine function, you can also just swap out your x and y columns in your table and you'll be fine. So you can just quickly sketch the graph. And this one is at +π/4. And we've got π/2. So I am going to sketch a graph of the sine function that's been restricted. And so the first value was -π/2, -1. So we're down here, -π/2, -1. And we've got -π/4, √2. So -√2. -π/4. It's right here. We got this function. This point. Wait a second. What did I do? This is √2/2 is 0.7. When I listed my values on my graph, I did π/4. And I didn't list that other one. No, hang on, what did I do? Okay, we've got 0.7 is not. Yeah, that's right. Sorry, I don't know what I was. Okay. And so then we've got 0, 0. And it's been a while, so I get stuck sometimes still. And hopefully I feel like it's getting better. But it's still hard what I'm doing. All right, so if I'm making it look easy, it's not. All right, so, and then my next value, 0, 0, π/4 is √2/2, which these are the same. All right, anyway, so we've got π/4 positive √2/2, and then we've got π/2 is π/2, 1. There we go. All right, and so we have this thing going on. And I'm going to try to draw this one. Let's go ahead and dash this one. See if I can dash it in here. Okay, just trying to get my skill back. I used to whip these graphs out. It's a lost art of graphing by hand because we all have all these fancy online gadgets now at our disposal. So, all right, there is it's like a zoomed in picture of my sine function, and then hopefully when I go to graph the Arc-Sine, I won't get as stumped. All right, so hopefully it's like riding a bike, you fall off, you just get back on. All right, so now I want to go ahead and plot the points of my Arc-Sine on this same graph, and then we'll try to put that identity function in there and see if we've got some symmetry. So we've got -1 out here, -1, and negative radical 2. So I'm over here, -1, negative radical 2. And let's see, we've got negative radical 2 over 2 was 0.7. So that was right in here. Negative radical 2, negative 0.7. And then we've got negative radical 4. Same point on there. We've got that one. Maybe I should make it a different color since they're 2 points on the same graph. And we've got 0, 0 on there, that point in common. And then we've got radical 2 over 2, which is right here, positive, and then pi over 4. We've got this point in common as well. And then we've got 1 more point, 1 comma pi over 2. So 1 over pi, 1 pi over 2. It's going to be about right here. Okay, and so this one I'm just going to draw dark because this is my focus. We've been graphing the sine function for 2 weeks now. But what is this other function doing? And what it's doing is it's going like this. Okay. And if you, oh, I wish I had, and I do, where are they? Here's one. Get my handy dandy yardstick out so I can, I wish I would have thought to get this out because it's stuck behind some cords. But I have this that I can kind of show you a little bit better. That identity function line. Is that perfect? Is that cheating? Can you get a large ruler to draw the line? I don't think I could do it justice. Let me see. Oh, I moved. Okay. But we've got this identity function line, and you can see it just got that perfect symmetry. And that's not too bad of a job. Let's see what I'm trying to say. So we've got this y equals x line. So that's that y. So we've got 3 things going on in here. And you can see the symmetry about that line. And that's one way that you can visually check to make sure that you have the inverse. If you have an online graphing feature of any kind, you can plug these functions in and, it'll check. Or you can, play around and practice sketching them by hand. Okay, very good. And that was pretty much my goal for today. It was to successfully sketch one of these functions. I do want to probably, I wanted to sketch also cosine, but this one took, it took quite a while. We're 35 minutes into the live stream, and I'm okay with calling it good for there, right there. Maybe I'll sketch the cosine next time and arc cosine. I really want to practice sketching some of the reciprocal functions. And so we might see it's hard because I'm just playing it by ear and kind of thinking about excuse me, thinking about the progression of the lesson um, and what I want to present next time. I may continue with the functions, and I might move on and start talking a little bit more about the reciprocal functions as well. I haven't decided yet. Um, yeah, so if you do watch my show, and if you do find it relevant, you're welcome to let me know. I do want to eventually have some sort of engagement with my audience so that I can find ways to support you in your math understanding. That's really my vision for this channel and this platform is supporting students with their math help if they need it. And yeah, that's enough chatting for now. Um, I will be back on Monday at between 6 and 7 p.m. Central Time. And again, thank you so much for watching. And bye for now. I'll see you next time.